Welcome to the video. Today's topic of discussion is so interesting. Yes, at least for me, it's really so interesting. And I think if you are a student of engineering or pure science, that is physics, chemistry, or mathematics, then you will find the same topic to be very interesting. And actually, this is known to you. I am just here giving you the summary of this topic. Euler's equation in our everyday life. Yes, if you notice carefully, means if you observe carefully, then you can see that in every sphere of life, Euler's equation is present. First, let's start with the Euler's identity. Euler's identity is what? It is e to the power I pi plus 1 is equal to 0. This is known as Euler's identity. You can see everything on the screen. E to the power I pi plus 1 is equal to 0. This is known as Euler's identity. This is also known as God's equation. And the reason for this, why it is called as God's equation, is that because in almost everything, means where science is there, Euler's identity is present. Okay, so e to the power I pi plus 1 is equal to 0. You know, if you expand e to the power I pi, what will be the result? The result is cos pi plus I sin pi, where I is what? I is I or iota. Either English letter, English small letter, I is used, or iota Greek letter is used, which is equal to root over of minus 1, that is a complex number. Pi, this is known to you, this is the ratio of the circumference of a circle to its diameter, which is known as pi. And E is there, e to the power I pi, that was mentioned, e to the power I pi. E is what? This is the base of the natural logarithm. Value is almost 2.7 plus, and value of pi is known to you 3.14 plus. Okay, you can see these numbers on the screen. Plus 1 and is equal to 0, so 1 is present, 0 is present. So 5 very fundamental numbers are present in the equation. And this equation you can find almost everywhere in the field of science and technology. Let's start with fluid mechanics. Again, one more thing is available, that is Euler's equation. Euler's equation for fluid motion. And in that case, you know that that is used only for inviscid flow, that is for non-viscous flow. Means effect of viscosity is neglected. And in case of very high speed flows, this can be done with a little approximation. Okay, very high speed flows, in that case actually inertia force becomes very, very greater than the diffusive force. And in that case, Euler's equation can be used. There is no need to use the Navier-Stokes equation, which is the full governing fluid flow equation for any kind of fluid flow. Navier-Stokes equation can be used where everything, all the effects can be captured. But in case of Euler's equation, only inviscid forces are neglected. Means the viscous part is neglected from, if you neglect viscous part from the Navier-Stokes equation, automatically it becomes Euler's equation, though Euler's equation was derived independently. Anyway, so I was talking about Euler's identity, Euler's equation, everything. Okay, so in case of fluid mechanics, you know, Euler's equations are present. Whether it is a flow of water through pipe or a flow of air around the wings of an airplane, wherever there is a flow, then in that case Euler's equations are present over there. Again, in case of rigid body dynamics, especially rotational motion, in that case also, where angular velocity is present, force is present, torque is present. For rotational motion, torque is required. So in those cases also, you will find the Euler's equation or Euler's identity. Means e to the power I plus I into something must be present, such as e to the power I omega. in various forms. Okay, this remains present. So initially I was talking about e to the power I pi plus 1 is equal to 0. How it becomes 0, that is known to you. If you expand e to the power I pi plus 1, then what is the result? E to the power I pi means cos pi plus I sin pi. Plus 1 is there. Cos pi, what is the value of this? Minus 1. Sin pi value is 0. So what is the result? Minus 1 plus 0 plus 1, which is equal to 0. So this is an identity known as Euler's identity, also known as Gauss equation. And another equation was Euler's equation, which is the Euler's equation for fluid motion. Okay, only for inviscid flows this equation is used. So the form e to the power I pi plus 1, this form, you will find almost every topic of science, almost, okay, not all, but almost, means actually many, I should rather say many topics. Okay, in many fields of science and engineering, you will find the same thing. So in case of rigid body dynamics, where angular motion is there, torque is there, forces are involved, in that case you will find the same thing. Again, in the analysis of AC circuits means alternating current circuits. In the field of electrical engineering, this is taught. So there also you will find the same thing, Euler's identity, Euler's equation present everywhere in the analysis, mathematical analysis of AC circuits. Again, in case of waves and vibrations, okay, whether it is a wave in the air or vibration of a guitar string, everywhere in the analysis, or it is ocean waves, in the analysis of waves and vibrations, you will frequently encounter with this term, with this equation, Euler's identity or Euler's equation. Again, AC circuits, yes, uses are there. Okay, again, in case of quantum mechanics, I'll make a separate video for that thing. Quantum mechanics, in the field of quantum mechanics also, you will get the application. Okay, again, in case in the field of electrical engineering, Fourier transforms are there, where by using Fourier transforms, signals are converted, are transformed into its component frequencies. So in that case also, that Euler's identity is present. Means involvement or use of Euler identity you will find almost in everything. That means in your everyday life, this equation is present, this equation is involved. Okay, that's why this equation is actually, the equation is very beautiful. It's so elegant to look at. Okay, and so short, so simple, and looks really beautiful. And its use is immense. In almost every field of science and technology, this equation is involved, and that is the importance of this equation. And those things make this equation more beautiful. The elegance of this equation is increased many folds this way. Okay, I think you can easily understand this video or the topic of this video if you are a student of science or engineering. Okay, I have here mentioned only few things. Okay, actually many points are there where this equation is used. Anyway, so this was all about it, today's topic, Euler's equation in our everyday life. Okay, so this is the end of this video. Thank you for watching this video.